Hello everyone, my name is Muhammad Lakman Nizamri.
Hi, my name is Fatin.
Hi, I'm Zati.
Today, our presentation is about risk management for urban sinkhole hazard, focusing on the Jalan Masjid India sinkhole incident in Kuala Lumpur. So this incident happened on 23rd August 2024 when an approximate 8-meter deep sinkhole suddenly opened along Jalan Masjid India. So the incident caused the death of tourists and triggered the major search and rescue operations. It also affected nearby businesses and disrupted public movement and reduced public confidence in urban infrastructure. The main issue is that the Kuala Lumpur is developing rapidly, but some of the infrastructures undergrounds, especially the sewer pipelines, is already aging. Because of this, risk management should not only focus on the emergency response after the failure happened, but it should also focus on the early hazard identifications and the prevention. So for this case, many people assume that the sinkhole was caused by the limestone cavities. However, the report explained that the area is located in the Kenny Hills formations, while the limestone layer is much more deeper underground. This means that the incident was more related to the infrastructure failures, especially in the aging sewer pipelines. The the failure process started when the sewer pipelines become weak due to the long-term exposure of the chemical corrosions. So then the wastewater will leak into the surrounding soil and slowly wash away the fine soil particles. So this process is called soil piping. Over time, an underground void form and expand until the surface could no longer support any loads. So finally, the ground will collapse and form a sinkhole. So the key hazard is not only the visible sinkhole, but the hidden underground damage that happened before the collapse. So that's all. Now I will explain. I will pass to the second presenter to explain the risk assessment.
Okay, next I will present to reduce the risk of future sinkholes. Several mitigation strategies are recommended. First, ground penetrating radar GPR can be used to detect underground voids before the ground collapse. Second, regular structural audit of old sewer network should be carried out using CCTV inspection robots and LIDAR technology. Damaged part can then be repaired early to prevent leakage and soil erosion. Third, urban planning control should be improved. Heavy construction and peeling wood near old sewer lines should be carefully assessed, and proper soil compaction must be ensured during development project. Fourth, IoT monitoring sensor can provide early warning by detecting pipe leaks and groundwater change before conditions become critical. If a sinkhole occurs, emergency response must be fast and coordinate. The affected area should be isolated immediately, and traffic should be stopped to prevent future ground instability. Water and sewer flow may also need to be diverted to avoid enlarging the cavity. Search and rescue operations should involve relevant agencies, and robots should be used to inspect hazardous underground space before rescue enter. After the rescue operation, the ground must be stabilized through grounding excavation and proper backfilling. In conclusion, the Jalan Masjid India sinkholes highlight the importance of proactive risk management. Early detection, regular inspection, continuous monitoring, and effective emergency response are essential to prevent similar incidents in the future. That's all from me. Thank you.
I'll be explaining the case risk assessment. The case assessment follows the concept of ISO 31000 framework, which include risk identification, risk analysis, evaluation, where the risk analysis is done using a 5 by 5 risk matrix. The formula used is risk score times equals to likelihood times consequence. Likelihood means how possible the event is to happen. It is ranked from 1 to 5, where 1 means rare and 5 means certain, and consequence means how serious the impact if an event happens. It is also ranked from 1 to 5, where 1 means insignificant and 5 means catastrophic. For the Jalan Masjid India case, the most serious risk is catastrophic surface collapse. This means a sudden opening of a sinkhole in a high pedestrian area, and the likelihood is rated as 3, and the consequences is rated as 5, which is catastrophic. So the risk score is 50. We classify this as an extreme risk. Another risk is subsurface cavity expansion, where the underground void continues to grow without any warning, and the likelihood is rated as 4, and the consequence is also 4, so the score is 60. This is classified as an extreme risk. Other risks include utility damage, foundation settlement, and localized pothole. though this may have lowest cost, but they will need monitoring if ever become critical. In risk evaluation, the extreme risks are considered intolerable for high-risk areas like Kuala Lumpur's Golden Triangle. The tolerance for infrastructure failure is very low because the area is packed with commercial and important for tourism. So the main point from this risk assessment is clear. The hidden underground defect must be detected early before they become a major disaster. Next, the third presenter will explain the mitigation strategies and emergency response.